This question is asked in GATE 2014. Read it first. Consider a 6-stage instruction pipeline where all the stages are perfectly balanced. Assume that there is no cycle time overhead of the pipelining. So they are saying that we are having a 6-stage instruction pipeline and all of them are balanced. Balanced means all the stages are taking the same time. And also they are saying that there is no overhead because of pipeline, which means generally when we apply pipeline, the time taken in each stage may increase because of the buffers and sometimes because of the uneven delays in the pipeline. But they are saying that all of them are balanced and there is there is just an assumption. Assume that they are assuming that pipeline is not putting in any more time. So if you are having 6 stages, they are saying that all these stages are having the same delays. When an application is executed on this 6-stage pipeline, the speed up achieved with respect to the non-pipelined execution if 25% of the instructions incur 2 pipeline stall cycles is. So they are talking about this speed up. We know that speed up is nothing but time taken to execute an instruction without pipeline divided by time taken to execute an instruction with pipeline. And what is the time taken to execute an instruction without pipeline? That depends on the number of stages and the time taken for each stage. But here they didn't mention anything about time taken for each stage, right? So it is number of stages, which is 6 into time taken for each stage. So since they didn't mention anything, we can safely assume here in this case, we can assume that time taken for each stage is 1 clock. Let me write it as TC. TC means 1 clock cycle. Okay, so 6 stages are there and each stage we are assuming that it is taking this many clock, 1 clock. The reason I am assuming that it is taking 1 clock is because in the denominator also we'll assume it as if it is 1 clock, then both these clocks will get cancelled and we get a constant number. That is the reason. Okay. Now we want to find out what is the time taken to execute an instruction on average using the pipeline. So in order to find it out, we have to analyze it in a different manner. So time taken to execute an instruction using a pipeline, in general it is 1 clock, isn't it? But then they are saying that 25% of the instructions are incurring 2 pipeline stall cycles, which means if we have 1, 2, 3, 4, 5, 6, if we have 6 cycles, they are saying that 25% of the instructions are having 2 stalls, which means the next instruction for such 25% instructions have to start after the 3rd stage. Therefore, for 25% of the instructions, time taken will be 3 clocks, and for remaining 75% time taken will be 1 clock. If you assume that total number of instructions are I, 25% of the instructions are having 2 stall cycles, right? 2 stall cycles is nothing but 1 instruction every 3 clocks. That is why you have to say that this 25% are going to take 3 clock cycles, and the remaining 75% of the instructions, they will be normal rate. The normal rate is nothing but clocks per instruction is 1. So 75% instructions are taking 1 clock cycle, right? Therefore, the time taken for the pipeline is going to be, for 25%, which means 0.25, it is going to be 3 clocks. So 3 clocks means 3 into TC, plus for the remaining 0.75, it is 1 clock. Alright, so you are going to get 1.5 TC. Got it? So some of the textbooks, they also analyze this type of question in a different manner, where different authors use different methods. Some of the textbooks, they also say that time taken for the pipeline, the average number of clocks for the pipeline is nothing but 1 plus stall instructions or stall frequency into stall penalty. So what does it mean? The average number of clocks required to execute an instruction in a pipelined processor is normally 1. When in case if you don't have any instructions, that might cause a stall, but because of the dependencies, some of the instructions will cause the stalls. And if we assume that the instructions which cause the stalls are represented by stall frequency, this is nothing but the percentage of instructions which cause stall. Let's say it is represented by stall frequency, then it is 1 plus stall frequency into stall penalty, right? So here they have mentioned that 1 plus stall frequency is 25%, which means 0.25 into stall penalty is 2, right? It is not 3, it is 2, because 1 is already written here. Got it? So even if you go with that method, 1.5. Are understanding this? In general, if there are no instructions which are causing stalls, then the number of clocks per instruction has to be 1, right? But then because of the stall instructions, it has to be more than 1. How much is that? That depends on the number of such instructions which causes stall and the number of cycles we might have to stall because of such instructions, both of them, right? And anyway we got 1.5. So this is the number of clocks that are required per instruction on average. But since we are talking about the time, we have to multiply with the time of each clock. This is the number of clocks and this is the time of each clock. Therefore, this is the time in seconds required on average to execute an instruction in a pipelined processor. Got it? So this is the time taken to execute an instruction in a pipeline processor, and without pipeline we have to execute them one after the other. Therefore 6 stages are there, and assuming that each stage is going to take TC, then it is the time 6 into TC, and in pipeline processor it is 1.5 into TC, right? So TC will get cancelled away. That is why they didn't mention about the clock at all. Even if they give the clock in the final computation or in the final answer, it doesn't matter, right? So it is going to be 60 divided by 15. So 4 is the speed up. Generally in a 6-stage pipeline, the speed up has to be 6, isn't it? But then because of these extra stalls and all this, the speed up has dropped from 6 to 4. The speed up will never be more than 6. It will definitely be less than 6, because in a 6-stage pipeline the maximum speed up we might get is 6. But because of these stalls, it is going to decrease. See, in case if the number of penalty, if the penalty decreases or if this one decreases, you can assume that you can get the speed up increasing. You can check it with various questions. See, this is the question which is done and the answer is 4, it is over, right? But what I want you to test is, substitute with different numbers here. Assume that the number of the stall instructions are more, and see what happens. Assume that the penalty is more and see what happens. Also decrease them and see what happens. What you will find out is, when either this factor decreases or this factor decreases, the number of clocks required will decrease, and so the speed up will increase. Just tell me one thing, if there are no instructions at all which are causing stall, then what do you think will be the speed up? If there are no instructions which are causing the stall, then this factor will go to 0. Therefore the number of clocks required for a pipeline processor in this case will be 1 exactly. If this is 1, if you substitute 1 here, then we are going to get 6 as the speed up. So which means speed up is complete 6. And when do we get 6? When the efficiency is 100. Then the efficiency can be computed as 100. If you remember, there is a relationship between the efficiency or utilization of the pipeline and the speed up and the number of stages. I told you, right? Speed up is equal to number of stages into efficiency. When these two are equal, then efficiency equal to 1, which means 100% efficiency. Got it? So some other questions which are possible on this one is, they will say that at 100% efficiency, the speed up is so and so. Then what does it mean? You can find out the number of stages in that case. If the efficiency is 100%, which means if E is 1, then speed up if they give you, then you can find out the number of stages, right? And then they can ask you some other questions like what is the number of stages, or different questions can be asked. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So First reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.